We're going to talk about cubed roots, but first let's review a little bit of square roots. If we look at letter A, we have our 5. We're just going to bring it down. We don't want to forget about it, but then we're going to ignore it for a while. So we're going to break down 28, 4 and 7. Bring my variables along for the ride, not doing anything with them yet. 4 can break down to 2 and 2. 7 is still there. It's prime. And then x cubed is 3x's and y is 1. Now, we don't have to draw them out, but I think sometimes it helps. So we're looking for pairs. Well, I have a pair of 2's, so I bring out a 2. I have a pair of x's, so I bring out an x. 7, x, and y don't have pairs, so they stay inside the radical. So now, that 5 that I forgot about, we multiply that with the 2 that we took out times the x. So 5 times 2 is 10, and we just have the 1x. And because the exponent is odd, it's 1, we use the absolute value bars. And then square root of 7xy. Those just get stuck together. So that's it. Now letter B, we're going to look at something a little bit more complicated because we have a fraction involved. So again, we're going to bring down the 1/3. Then we're just going to look at our radicand. 180 can be split up into 10 and 18. Just bring the variables along for the ride right now. 10 is 5 and 2, 18 is 2 and 9, 5 is prime, 2's are prime, we break down 9 into 3's. So I have a 5, 2 2's, 2 3's, and then I look at my variables. I have 4 a's and 5 b's. Oh, and I forgot a b. So we don't want to forget that. So I have an extra b here. I don't want to forget it, which I did. So we're looking for pairs. I got a pair of 2's, I bring it out. A pair of 3's, I bring it out. 2 pairs of a's, so I bring out 2 a's, and 2 pairs of b's, and I bring them out. 5 and the b are still stuck inside. Now, we also had our 1/3 from the beginning. So we multiply all our numbers together. 1/3 times 2 times 3 is 2. A times a is a squared. B times b is b squared. And the square root of 5b is what we have left. Now, the exponents on a and b are even, so we don't need the absolute value bars. So it's just 2a squared b squared times the square root of 5b. So it's just the same steps that we've been doing. Remember, variables are the same as with our numbers. We look for pairs, and then we bring them out. The difference with variables is they tell you how many of each there is. You don't have to break them down. All right, letter C, changing a repeating decimal to a fraction. First, we set x equal to the number we're changing. So x equals 3.45 repeated. Now we need to multiply by something so the decimal is before the repeating part. Well, it already is. It's right before the 4 and the 5, so we don't have to do that. So this is our first equation. Now we want to have the decimal after the repeating stuff, so after the 5. So that's 2 places, so we multiply by 100. So 100 times x is 100x, 100 times 3.45 repeated is 345.45 repeated. And then we subtract the 2 equations. So I'm just going to rewrite this one down here and I subtract. So 100x minus x is 99x. 345.45 repeated minus 3.45 repeated. The repeated parts cancel out, which is what we're doing. 345 minus 3 is 342. And now I have 99x equals 342. I divide by 99. X equals 342 over 99, but I can simplify. I can divide by 3, and I can divide by 3 again. Or I can just divide by 9. Either way, we get 38 over 11, or 3 and 5 over 11. It doesn't matter to me which way we do it. Alright, so now we're looking at cubed roots. So now we have something that looks like this. We have an index here. It's 3. That tells us we want a cubed root. So what was the index before for square root? Well, it was a 2. We just don't write it. There's no such thing as a first root, so we look at a square root. What is the a called? Well, that's the radicand. All right, so our differences between cubed root and square root. Now we're looking for groups of 3 instead of pairs because it's a 3 index. It's a cubed root. So that's not much different. We don't need any absolute value bars because we can take the cubed root of negative numbers. So that kind of goes into number 3 here. If the radicand is negative, just take it out. Don't get rid of it, but put it with our answer. So for example, we can't do the square root of negative 36. Not yet anyways. Now the cubed root of negative 8, we can. It's negative 2, because negative 2 times negative 2 times negative 2 is a negative 8. Negative times a negative is a positive, times another negative is negative. So we can do that. All right, well, here's a couple examples. Whoop. So first example, the cube root of 200. So we break down 200 into 10 and 20. 10 is 5 and 2, 20 is 4 and 5, and then we can break down that 5 or 4 into 2, 2. So we have 2 5s and 3 2s, just like we've done before. We've broken down 200 before. Notice I had the cubed root on all of those. I don't want to forget that and think it's a square root. So I highlighted that to make sure that we remember it. Now instead of pairs, we're looking for groups of 3. Well, I have a group of 3. I have 3 2s. So just like when I had a pair before, if I have a group of 3s, I bring out a 2 for that group. What doesn't have a group, a 3, are 5s, so they stay inside the radical. Then, just like before, anything on the outside we multiply together, well, there's only a 2. Anything on the inside we multiply together. 5 times 5 is 25, so it's 2 times the cubed root of 25. Don't forget the 3. That's it. So we're looking for groups of 3 instead of 2. The second example here, we have 4x out in front. So again, I'm going to draw that arrow down here, and we have a negative in our radicand. So I'm just going to take it out and put it with our answer, and then we're just going to forget about it. So 108 can be turned into 4 and 27. 4 is 2 and 2, 27 is 9 and 3, and then 9 we can do into 3 and 3. So we have 2 2s, 3 3s, and I have 5 x's. So we're looking for groups of 3. Well, I have a group of 3s and a group of x's. So I bring out a 3 and I bring out an x. What doesn't have a group? Well, the 2 2s, so they stay inside, and the 2 x's, they stay inside. And we still had the negative in the 4x from the beginning of the problem. So we multiply all this together. Negative 4 times 3 is negative 12. X times x is x squared. 2 times 2 is 4, and x times x is x squared. Don't forget our cubed root here. So that's all we're looking at. Now, looking at our variables, remember we could divide by 2 with the square roots? Well, with cubed roots, we can divide by 3. So, 3 goes into 5 one time, so we bring out 1x, and we have a remainder of 2. So 2 are still left inside, and that's what we're doing. So pretty much the same thing we did with square roots, but now we are looking at 3's. All right, we got 2 more examples. Let's take a look at these. So again, 5a, we're going to bring it down here. The negative, I'm going to bring it down here as well, and then I'm just going to do the rest of the problem. 128 can be broken into 16 and 8. 16 is 4 and 4, 8 is 4 and 2, and then we can break our 4's into 2's. So I have 7 2's, 3 a's, or 5 a's, and 6 b's. So I'm looking for groups of 3. I have 2 groups of 2's, so I bring out 2 2's. I have a group of a's, so I bring out an a. And I have 2 groups of b's, so I bring out 2 b's. What doesn't have a group? A 2 and the 2 a's, so they stay inside. Don't forget our cubed root, our 3 there. Now we multiply all that we took out with the negative 5a that we had before. So we get negative 20, a squared, because we had 2 a's, b squared, because we had 2 b's. Inside we have a 2, and a squared, because we had 2 a's. And don't forget our cubed root. Now what we could have noticed when we got to here with our 4's, we could have just taken it out as a 4, because it's a group of 3, and gone a little bit further. So we could take out that group, and these 2 2's would be that 4, so that's the same thing. Or you can write it out all the way, it doesn't matter. Let's look at one more example. So we have 1/2 the cubed root of 216 m cubed and 13th. So we bring the 1/2 down to the bottom, and then we just keep working with the other stuff. 216 is 6 and 36, 6 is 2 and 3, 36 is 6 and 6. 2 and 3 are prime, but 6 and 6 give me 2 and 3, 2 and 3. I have my m's and n's, and I'm not going to write them all out this time because that's a lot, so I'm just going to divide them, and we'll talk about that in a second. So I have a group of 2's, so I bring on a 2. I have a group of 3's, I bring on a 3. So I have no numbers left over. So I have 1/2 times 2 times 3 gives me 3. Now looking at the variables, the cubed root of m cubed, well, 3 goes into 3 one time. We have one group of 3 with no leftovers, so it's just m. So I bring out an m. With n to the 13th, 3 goes into 13 4 times, so I'm going to bring out 4 n's, and I forgot to write that. Bring out 4 n's, but I had one remainder, so I have one still stuck in the radicand. So that's what we're looking at here. And then I just push it all together. Again, I forgot the 4. So 3m n to the 4th cubed root of n.